Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We are continuing with Chapter 10 today in geometry. Chapter 10 is mostly about circles. We got tangents, secants, chords, certain things. Yeah, there's some rules and properties we're going to learn about with angles, inscribed angles, all those kind of things. We haven't really talked about much of that yet. How to write an equation for a circle in standard form, all those kind of things. And so, got a lot of vocab today. A lot of it might be... some of it will be review, but some of it will not. So make sure you guys, watch the video, go back and review if you need to, and hopefully it won't be too bad of a lesson today. So today's lesson is 10.1. It says use properties of tangents. Our central question is, how do we use properties of tangents to solve problems? So no warm-up today. So we have some definitions. Let's get into that here. And so some of these are like, what I would call, formal definitions, which is like the actual definition mathematicians use, but you guys don't need to know I don't think you need to know the formal definitions. It's just going to confuse you a little bit. So the formal definition of a circle is a set of points in a plane that are equidistant, or what? Equidistant from a given point. But you guys know a circle is literally just this, right? And so basically, the actual round part of the circle, those are all the points that are equidistant from the center, right? These are all the same distance, okay, which is the radius, basically. So that's kind of what the formal definition is, but you guys know if you draw a circle what it looks like, right? So a circle is this, and then they're all the same distance from, all the points that are the same distance from the radius in the center here, okay? Like as we talked about, the center is the point from which all points of the circle, what points? All points of the circle are equidistant. A radius is a segment from the center of a circle, from the what? Center of a circle to any point on a circle. So if we draw a circle here, we draw the center, basically go from the center to any edge is going to be the radius, right? Okay. All right. Chord, this is pronounced chord, is a segment whose endpoints, whose what? Endpoints are on a circle. So for example, if we draw a circle here, a chord would be basically 2 points on the circle, and then they're connected in the middle like that, okay? The chord can go through the center of the circle, and that's going to be another definition, okay? So chords don't have to go through the center of the circle, but when they do, a diameter, say diameter, is a chord that contains, that what? Contains the center of a circle. So basically a diameter is a chord that goes right through the center of the circle. It's not going to be perfect, but this is a diameter, okay? And also, if we recall from a while ago, diameter equals how many radii? Well, here's a radius, and here's a radius. It equals 2 radii, or a radius equals the diameter over 2, right? There's 2 ways to write that, okay? Half diameter, or, let's write 1/2 diameter, or diameter over 2, okay? Secant is similar to a chord. It's a line that intersects, intersects a circle on 2 points. Let's draw the secant over here. But basically a secant, whereas a chord is on the line or on the circle, a secant is actually going to go past the circle. It's going to be like a line that just intersects here. So it kind of intersects the circle in 2 points, but it goes beyond the circle, okay? All right, so that intersects at 2 points, by the way. A tangent intersects the circle at exactly 1 point. How many points? 1 point. So it's similar to this is a secant right here. Okay, a tangent is similar, except it's only going to intersect very touching the edge like this. Okay, so we intersect at 1 point, and that's going to be a tangent. Okay, it's only going to touch it at 1 point. All right. Very cool. We have an example here. It says, determine whether the line ray segment is best described as a radius, chord, diameter, secant, or tangent of circle C. This is circle C right here. Why don't you guys pause the video and see if you can figure it out. Go ahead. All right, so BC, looks like this is a line segment. BC is from the center to the edge. What is that called? From the center edge of a circle, it's called a radius. Okay. Then we have, this is line EA. Let's use a better color so we can see this here. Line EA, which goes like this. Oops. Goes like this and goes beyond the circle. It crosses 2 times on the circle, not once. So what's that called? Is that a secant or tangent? It's a secant. okay? Because it goes beyond the circle, and it touches the circle twice. How about DE? DE goes like this. It is a ray, but rays could also be other things too. So this is a ray because it starts at D and goes to the left. How many times does it touch the circle? Touch the circle once. What do you think this is going to be? This is going to be a tangent because it only touches the circle once, and it goes on kind of forever. I guess you can have a tangent that's not like an actual. You can have a line segment that's a tangent too, but the definition says a line, but it could be a line, ray, segment, anything like that. Okay? All right, example 2. We're looking for lengths and circles in the coordinate plane. So we're looking for the radius and diameter of these shapes here. We're looking at this graph over here, right? So let's do one together, and you guys will try one. So if you want to pause the video and see how you do, you can do that as well. All right, radius of circle A. So radius, is that all the way across or halfway across? That is all the way across. So let's go from the center to the edge. How many boxes is that from the center to the edge of circle A? That's 2. All right, and then the diameter of A, you need to do it from the graph. So if you go all the way across, it's 2 radii, right? All the way across is going to be 1, 2, 4 boxes. Or remember, you can do the diameter equals 2 radii, and the radius is 2, right, which also equals 4. Okay. Why don't you guys go ahead and do C and D, which is radius of B and diameter of B. Go ahead. All right, new color here. So radius of B. So B, and you can go any direction you want as long as it's like all the way across. So I'm gonna go. Let's see here. It's kind of tough. I'll just go to the right from the center to the edge. How many boxes is that? That is 4. Okay. How about the diameter of B? That's all the way across, 2 radii. That's gonna be how many boxes? It's gonna be 8. And again, the diameter equals 2 times the radius, or 2 times 4, which equals 8. Okay? All right, we have some checkpoints here. Why don't you guys, it says, what would you describe AB as in the in example 1, which is up here? And also, like, find the radius of C and diameter of D in the diagram to the right. Go ahead and pause the video, see how you do. Okay, example 1, AB is this right here in this first diagram. What is that? That is a diameter. It's all the way across. Okay. How about the radius of C? Well, the radius of C is from the center to the edge. How many boxes is that? That's going to be 3. And how about the diameter of D? That's all the way across. That is 2 boxes. Awesome. All right, next thing's a little bit tricky, okay? Well, not super tricky, I guess. It's some people it takes a little bit more to see. So we're looking for common tangents, okay? So common tangents are going to be lines that we can draw that only touch each circle once, okay? They only touch each circle once, okay? So let's go ahead and do, I don't know. How about I draw one common tangent, and you guys see if you can find the rest, okay? Between A and B, there should be 5 total lines you can draw. Let's draw 1, okay? So I'm going to draw 1. Do you see where I can draw a line that would touch the circle only once? Well, I can go like this, right? See how it touches each circle only once? Okay, so that would be a common tangent, that's called. Why don't you guys go ahead and see if you can find between A and B the rest of the common tangents. So there's going to be 4 more lines to draw between these 2 diagrams. Okay, go ahead and see how you do. All right, well, we can obviously go not even obviously, but for A, we can go the opposite side, right, and go like this. Not perfect, but it gets the job done. There's actually 1 more on A. Do you see where it is? Yeah, because these are not overlapping circles, we can also go right in the middle, and it only touches once, okay? Nice. How about B? Well, we have the same thing. It's going to touch the edge of both of these and the edge of both of these. We can't do the middle, though, because it'll touch, if it goes through the middle, it's going to touch the circles multiple times, which doesn't work, right? So those are our common tangents. All right, awesome. Okay, so let's move on here. Now we need to go ahead and we're going to verify whether something is tangent to a circle, okay? And basically, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle, okay? Only if it's perpendicular to the radius of the circle. So we're going to have these triangles here, and what we're going to do, we have to prove that it's at a right angle right here, right? Well, what kind of triangle does that look like right there, for example 4? That's a right triangle. So if we can prove it's a right triangle, It proves they're perpendicular because it proves that that's a right angle there, right? Proves perpendicular. And we're going to use, what are we going to use to prove, like, what kind of theorem or tool are we going to use to be able to show that this is a right triangle? What do you guys think? Hopefully you said Pythagorean theorem, because that is the right tool, okay? That is only used for right triangles. If you said something about, like, trig functions, that would also be a good thing, but in this case, we're going to use the Pythagorean theorem, okay? All right, so we need to do, remember, what is Pythagorean theorem again? It's a squared plus b squared equals c squared, right? So we need to figure out our a, b, and c. C is the hypotenuse. That's the only way you can mess it up, okay? So what's the hypotenuse of this triangle here? It's 26, right? So we're going to do 10 squared plus 24 squared equals 26 squared. And we're going to see if that's true or false. Why don't you guys go ahead and try to simplify this and see how you do. All right, so 10 squared is going to be 100. 24 squared is going to be 576. And 26 squared is 676. And 100 plus 576 is going to be 676. Are these numbers equal? They are. So this is going to be yes. And it's a right triangle. It means that it's perpendicular, and ST is tangent. And segment ST is tangent. So for the theorem says that if it's tangent, it has to be at a right angle. It has to be perpendicular, which means it's a right angle. So we're kind of using a kind of roundabout tool to make this happen, but it's basically the way we can kind of do this here, okay? All right, sounds good. Why don't you guys go ahead and do checkpoints 5 and 6, very similar. This one's a little weird, though, so it's interesting. Okay, so yeah, go ahead and do 5 and 6. This is actually, this whole thing right here is 7, by the way, so it's kind of weird, but let's go ahead and try that. Oh, wait, actually, no, it's not. I goofed up. Okay, number 6 is a little bit different, okay? So this is the radius here, is 12. This is also going to be 12, so what's this entire thing going to be here? It's going to be 19, okay? I was wondering, that was kind of weird there, but yeah. So that's kind of a weird thing with this one, but yeah, see if it works. Go ahead and try these. All right, so we're going to do Pythagorean theorem. So we got 5 squared. Oh, this is actually goofed up here. I think my notes are incorrect, actually, on this. I just caught this. So this would actually be 13 right here, okay? So I'm going to have to fix that in my notes. So we have 5 squared plus 12 squared equals 5 plus 8, which is 13 squared. So 5 squared is going to be 25. 12 squared is 144. And 13 squared, I believe, is 169. And yeah, so then we get 25 plus 144 is 169, which equals 169. Is this a right triangle? Yes, it is. It's a right triangle, and that implies that it's a tangent. It's congruent, or it's at a right angle. Okay. All right. That's a weird G. Okay. Okay, let's try the second one here. So number 6. We have this right triangle here. So we got to do a squared plus b squared equals c squared. So we got 12 squared plus 16 squared equals 12 plus 7 is 19 squared. I need my calculator here since I'm calculating this in real time here. So 12 squared I know is 144. 16 squared should be 256. Yep. And 19 squared is 361. Okay, and then 144 plus 256 is 400. Does 400 equal 361? It does not. So, in this case, that's not the case. This is not tangent. Okay, it's not a right triangle, which means it's not at a right angle, which means it's not tangent. So tangents are going to be at a right angle to the radius. Okay? All right, last thing we got here. Well, actually, a couple more things. I lied. I apologize. So, example 5. We're saying that B is a point of tangency. We're finding the radius of circle C. So now in this case, we're going the opposite direction. We know that AB is tangent, and we're trying to find the radius. Okay. So for this one, we're going to do the same thing. So we're going to write this. We're going to write solve for R, the radius, using Pythagorean theorem. Okay, so we're going to do the same thing here, but it's a little bit weird, okay? So it's going to be a squared plus b squared equals c squared. What's our a and b for this one? Well, for this case, it's going to be r squared, which is one of the legs, plus 77 squared equals, well, what's C? What's our hypotenuse here? Well, it's not just 49, it's not just r, it's going to be r plus 49 squared. Okay, it's a little bit weird, okay? All right. So yeah, so let's keep going here. So now we got to solve for r. Let's see how we do here. So we got r squared, 77 squared is 5,929. Now, how do we solve this? It's a little bit tricky here. We're going to have, to expand this out and use distributive property, okay? So we have r plus 49. We have two of them, so we're going to multiply r plus 49 times itself twice, okay? And you can't just do the 2 to the r of the 49. You got to expand it out and do distributive property, okay? So let's distribute this. We got r times r. If you want to pause the video and see how you do to do distributive property, that'd be awesome. So we got r squared plus 5,929 equals r squared plus 49r plus 49r plus, and 49 times 49 is 2,401. Okay. We have to combine like terms now. So we have r squared plus 5,929. 49r plus 49r, these are like terms here. It's going to be 98r plus 2401. Okay. And we're not going to factor here. We're actually going to, we're going to get all the r's. So if we factor, we're going to go kind of back to where the start, which is not going to help us. So we're actually going to get let's try to get all the r squares on one side here first, okay? It's a little bit weird because we haven't really done much of this, but you'll see what happens when we do that. So how do I move r squared from one side to the other? I'm going to subtract it, right? You can add or subtract. And what's going to happen when you subtract them? Well, they're going to cancel. Ooh, that's interesting. So now those are going to cancel, and we get 5,929 equals 98r, plus 2401. Okay. Now we need to solve for r by getting 98r by itself. How do we do that? We'll subtract 2401. And we get, it's going to go over here, we have 3,528 equals 98r. Divide by 98 to solve for r. And r is going to equal 36. That's the radius. That's kind of a tricky one. That's a lot of things going on here. Okay? All right. Okay. Let's do example. Let's talk about one more theorem here, and then we'll do another example, and you guys will try a couple of checkpoints if you would like. Okay? All right. So tangent segments from a common external point, S, are going to be congruent. They're going to be what? Congruent. So basically, if they're tangent to the same point outside the circle, you just set them equal and you solve. Okay? So let's do this here. So we have this drawing. So here's Q. These are both tangents to the circle from that point. So what do we know about 32 and 3x plus 5? They are congruent, which means we set them what? Set them equal. So 3x plus 5 equals 32. Why don't you guys go ahead and solve that if you want. We're going to subtract 5. 3x equals 32 minus 5 is 27. Divide by 3. We get x equals 9. Ta-da! So that's it. It's just kind of a rule. If the tangents are tangent to the circle from the same external point, they're going to be congruent. All right, we have a couple checkpoints here. Why don't you guys go ahead and see how you do, and we'll go through it in a second. All right, sounds good. So, here we go. So here's a point of tangency. So we're going to do Pythagorean theorem again. So we have r squared plus 56 squared equals, now in parentheses, we have r plus 32 squared. Okay? So 56 squared is 3,136. This is going to be r plus, here, let's do it over to the left over here. I'll speak some room. So we have r plus 32. That's r plus 32. Dang it. Okay, r times r is r squared. R times 32 is 32r. 32 times r is 32r. And 32 times 32 is 1,024. Combine like terms, we get r squared plus 64r plus 1,024. Okay, so we can plug that in over here. So we have r squared plus 64r plus 1,024. Okay, subtract r squared to get rid of those. 3,136 equals 64r plus 1,024. Get the 64R by itself by subtracting 1024. And we get, on the left-hand side, we're going to get 2,112 equals 64R. Oops. Divide by 64. And we get R equals 33. All right, last example. We know these are tangents at S and T, and they're both tangent, the same distance. Yeah, they're both tangent to the circle at point R, so they're going to be the same distance. So what do we do to them? Set them equal. So we got x squared equals 49. How do we solve this now? Well, we would do square root both sides. We get x equals, usually it's plus or minus 7 when you do this, but can we have a negative distance or no? X is going to equal 7 because distance is never negative. And that's our answer. All right, that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.